Good evening, everybody. Welcome to night 4 of Lambda School's Introduction to Web Development. This is night 4 out of 8, so we're just finishing up our first week. So earlier this week, we learned all about HTML and CSS, which are the two languages that we use to present content on the web. So we learned how to put content up and style it using HTML and CSS. And then last night, we started on JavaScript, which is a programming language used to do all sorts of cool things. So JavaScript's a little more advanced, and that means that we are going to be spending the rest of this course looking at JavaScript. So you guys had a little introduction to that last night. We're going to go over more of it tonight, and then all of next week, all 4 nights, we will be doing JavaScript. So I hope you guys enjoyed your introduction to it and are looking forward to learning how to do some more cool stuff with it tonight. Tonight is going to be all about control flow. We're going to explore this idea of if-else statements in a bit more detail, and then go over looping as well. So before we get into the coding for tonight, I want to talk to you guys a little bit more about Lambda School. As always, feel free to ask questions throughout the night. I'll get to as many as I can at the end and maybe answer a few along the way as well. So yeah, let's talk a little bit about Lambda School, and then we can start coding. So what I wanted to talk to you guys about tonight was get a little deeper into the curriculum. So you guys have been asking some great questions about the curriculum, and now that you know a few languages, you have a little more context for talking in a little bit more detail about what you will be learning in the main curriculum at Lambda School. So it is oriented towards web development. So really the focus of the Lambda School curriculum is getting you to the point where you can build websites and web applications using 3 languages that we've been working with in this very introduction course. So not only will you be going into a lot more detail in HTML and CSS, but you'll also be learning useful frameworks that will help you especially do CSS in a much more sophisticated way. So I know on Tuesday I mentioned things like preprocessors and frameworks, so you'll also be learning how to work with those. And I think you'll find, especially after playing a little bit with raw CSS, that those are really powerful, wonderful tools. Beyond the markup stuff, we'll also be going very deep into JavaScript. So in terms of front-end JavaScript, which is to say JavaScript that deals with the visual part of the web, you'll be working with a framework called React. And once again, a framework is like a layer that we put on top of the language that just makes it a little easier to use and makes getting working content up even quicker. So you'll be playing, of course, with JavaScript as a language, but also with this React framework. And then, of course, we'll be diving totally into the back end. So the back end is something I've mentioned in this course, but not really something we unfortunately have time to go over in this course. So the back end is all about databases, processing submitted data, retrieving data from the banks, just moving around data. So you'll be learning to do that with JavaScript and with some database languages as well. So by the end of that, you'll have all the skills you need to create working, dynamic, beautiful, sophisticated web applications. And those are extremely practical skills, so practical. Beyond that, though, we want to give you even more skills than that. So we actually do a little bit of a computer science-oriented piece where we teach you some data stuff with Python. We teach you a little bit of C, which is a object-oriented language. And to answer a couple questions coming to Zoom right now, yes, when we're doing the database portion, we will cover SQL. We will not be going over assembly language. So none of the low-level computer stuff. That stuff can be really interesting and is something I think is very much worth looking into on your own, but is not a necessary skill for most web developer jobs. So there you go. That's a little bit about what you'll be learning in Lambda School. As I've already mentioned, if you guys are interested in getting started on that application process or just have some questions, reach out to Karen Zachary in Slack and she can get you going on that. Anyways, enough about what you will learn. Let's go into what you will learn tonight because that's happening right now. So let's go over a little bit of what we learned last night with the basics of JavaScript, and then we will dive into some new topics. So I am going to share my screen and then we will get going. All right. Okay. So over here I have Replit up as a little reminder. Replit is the sandbox environment that is going to be our best friend for the rest of this course. So it's a really great place for us to experiment with small bits of JavaScript code. And as a side, Replit isn't just for JavaScript. So if you're playing with other languages on the side, feel free to look at some of the other options for Replit. We like Replit because we can write our code straight on here. So we can write in a small bit of code, and then when we press the run button, we can see that the last line of code appears over here in green. And there's this concept called code resolution. And so that's this idea that every chunk of code resolves to something. So some bits of code, I guess, don't really resolve to anything. Like I've talked about how a variable declaration statement resolves to undefined. So some things create results in memory or produce text on the console, like console log, but a lot of bits of code resolve to some sort of value. So it's a very good practice to ask yourself constantly, what does this bit of code resolve to? Does it resolve to undefined? If not, does it resolve to a string or to a number? In this case, of course, when we're adding two numbers, we know that that's going to resolve to another number, in this case, 13. So Replit is this great way of giving us instant feedback about at least what one of our lines of code are doing. It's also a nice way to just run the code really quickly. So beyond Replit, let's do a little reminder about variable declarations and what's going on here. So these first two lines of code are both variable declaration statements. We've created variables called X and Y that are stored in memory. And think of these as little labels that we can use to access a piece of data. In the case of line 1, that bit of data is the number 7. In the case of line 2, it's the number 6. So now anywhere in our code, we can access X and Y using the names of the variable. And these things will turn into the numbers that they refer to when we plug them into a statement, such as this addition on line 3. Other things to keep in mind are that numbers are not the only bit of data we can create. We could also create things like strings. We can also create Booleans, which represent the idea of either true or false, on or off. So learning JavaScript is going to be, of course, equal to the Boolean of true. We also have things like undefined and null, which represent missing data. So you have to always ask yourself, what is the type of item that I'm creating? When you create a variable, what actually are you creating? Is it a number? Is it a Boolean? Is it a string? Maybe it's something more advanced like a function, which we'll explore on Monday. Another thing you need to explore when you're creating variables in JavaScript is this idea of, should my variable be constant or not? Constant means that the value should never ever change, whereas if you use the keyword let, that's going to be for a variable that should change at some point. So the example I shared with you last night was if we were trying to keep track of a user's age on a web app, I'm going to make that 17 because the idea of 7-year-olds using web app kind of scares me, even though that's probably what's happening now. So if we have a web app with a user whose age is 17, that would be a problem because what if our user uses our app over the course of a year? At some point, their age is no longer going to be 17, and we need to update that in memory. That's when we would use something like let. Let says, okay, age is going to be equal to 17 for now at least, and we can later in our code increment it. So we could redefine it to 18 or 38 or 48, whatever we want. Or I want to remind you of a little operator I taught you last night. So this is the plus plus operator. So line 1 says, let's create a non-constant variable called age, set equal to the number 17. Line 2 is saying, let's increment that value of age by 1. And remember, this plus plus operator only works if we have a non-constant variable. We'll get an error if we try to increment a constant variable because then it wouldn't be constant. And so on line 3, we can just look up the value of age and see that it in fact has incremented. So we can use the plus plus operator however much we want to just keep incrementing this value. If instead we wanted to decrement the value, we just do minus minus. So remember that plus, plus, and minus, minus actually change the value of whatever variable we're working with. And these are going to be really important operators for loops, and we're going to be looking at loops a little later. So I wanted to review those with you, and then I'll just go over it again really quickly at the end when we get to looping. And looping's really fun, so I'm excited to get to that. All right, so there's a little brief review of some of the things we saw last night. The last thing I wanted to review for you was the if-else statement. All right, so we have if and else. Okay, so, and I'm seeing, sorry, let me pause this for a minute. I'm seeing a question about if everyone can see my screen. So I'm going to just pause for a minute and make sure that people can. Let me double check the chat from you guys. Sorry, 1 second. Okay, yep, everyone can see my screen. That's good. It wouldn't be very good lesson on JavaScript if you couldn't see me writing the JavaScript. Thank you guys. Okay, back to the if-else statement. All right, so the if-else statement is what's called a conditional. And this is a really common case in programming. If you want an interesting bit of code, chances are you want it to behave in one way sometimes and in another way other times. And that's what the if-else statement is for. So one example I like to use with the if-else statement is this idea of, is it raining? So oftentimes our behavior might be changed by if it's raining or not. So if we had some sort of value that kept track of raining, and right now for line 1, I have just hard-coded in that raining is equal to true. In a real web application scenario, we could do something really sophisticated here. This might be a bit of code that actually queried a live database about weather in your area and actually detected in real time if it was raining or not. That's not the simplest thing to do, but it's actually not that hard to do either. So that's something really cool that you guys are going to be able to learn in the Lambda main curriculum, is to actually work with things called APIs that give you access to live, interesting data. So we have to mock things out a little bit at the start, but I want you guys to be thinking about what this would look like in a real web app, which is that we would want a variable that changed based on if it was actually raining for our user or not. So if, for example, we were building some sort of what to wear app, we might want to know if it's raining or not. So if it's raining, we would want our app to tell our user, wear a raincoat. And otherwise, we might tell our user, wear a tank top. So in this way, we can actually, based on something like if it were raining or not, we can actually have our web app behave in a different way. So because raining is set to true right now, it's going to log out wear a raincoat. If we changed raining to false, then it could log out wear a tank top. So this is a pretty simple if-else statement. We only have two different, or one line inside of the if and one line inside of the else. So this is the optional bit of code that runs if it's raining, and this is the optional bit of code that it runs when it's not raining. But inside this if statement could be a whole mess of code. It could be hundreds of lines of code that only run whenever it's raining, and the same in the else. And remember that the if always runs if this is true, and the else always runs if it's false. So we'll always get one or the other, but never both. So there's a little basic review of the if-else statement. We're going to be diving a lot deeper into some cool things we can do with it and some cool things we can do with this condition up here. So let's go ahead and introduce some new material now. The first thing I want to talk to you guys about is something called scope. And I'm actually going to get rid of my else block just for right now. So now we just have one optional line of code here that only runs if it's raining. So let me talk about scope. So everywhere on this, on this page exists something called scope. And scope is kind of like, where are you in terms of the code? So think about it this way. If you're walking around your neighborhood, you're out in public. And the rules are a little different. You're kind of expected to behave and dress in a certain nicer, more formal way. But let's say you go into your house and you live with your family or with roommates, and you're in the living room. So that's more of a private space, but it's still kind of this communal space, and the rules are slightly different there, but still, you know, maybe certain, you should probably wear your pants. But if you go in your room, that's your own private space, and the rules are even different in there. So we can think about kind of the same analogy in code. So when we're writing code out here, like line 2, that's the global scope. That's the most public place in the code. Everything is kind of free and accessible. If you want a little bit of privacy in your variables you're creating, you might dip into a scope like the if block. So in here, this is almost like being inside your house or inside your room with the closed door. There's a little bit more privacy in the code you're writing. So you might be wondering, what in the world do I mean by privacy? I'll show you. It really just has to do with availability of variables. So whenever you declare a variable, you're declaring it in a certain scope. So up here, as I mentioned, this is called the global scope. So on line 4, I created a variable called raining, and it's in the global scope. So think of the global scope as being the most public. So anything in the global scope is accessible everywhere. So of course I can, if I wanted to try to console log rain, this raining variable, I would have to spell it right. But if I wanted to console log this down on line 10, I could do that. You know, once we've declared this, we can access the variable. That's the whole point of declaring variables. And something that you might take for granted is that you can also access it in here. If I wanted to also just console log the value of raining, inside the, well, this would have to be true, so it actually runs. Inside of the if scope, I'm able to access this variable. So the big takeaway here is that this global variable is accessible everywhere. Remember how when I introduced you to things like math and console, I called them global objects? That's because they exist in the global scope, which means that they are accessible anywhere in your code. As you might have guessed though, not all variables are global, which means not all variables are accessible everywhere. So let's say that I created a variable inside of my if statement. We'll call this secret if variable. And I'm going to just set it equal to the word squash. Okay, so I have this totally unrelated to raining, unless we're trying to play squash outside, this secret if variable that I've declared inside of the if scope. And the reason we know it's in the if scope is just literally because it's in between the two if curly brackets. And as you might have guessed, if we had an else statement, there's also an else scope. So whenever I teach you a new thing that creates scope in this course, I'll mention that. But for right now, we can just think about if and else's as having scope. So let's say that I try to console log my secret if variable. Well, that totally works. It logged out to the console. And that's because I'm inside of the scope, so I'm allowed to access it. But let's try and console log it back in the global scope. We get that reference error. Secret if variable is not defined. So it turns out that everything in the global scope is available everywhere, but anything in the if scope is only available in the if scope. So to use another ridiculous metaphor to try to drive this home, think about the old saying, what happens in Vegas stays in Vegas. It's kind of like that when you're writing an if statement. What happens in the if scope stays in the if scope. And this is really useful because it turns out that it's another thing that's built into the language that kind of forces us to be good programmers. If we want to use something globally, we should create it globally. And it's nice to be able to create variables within scope block like this and just have them disappear, because if we were creating something like an x value, we might, I don't know why x is equal to squash, but we might want to use the variable name x again at different places in the code, and we don't have to worry about creating a new variable or redefining something. We know that because we created it in the scope, that it's going to exist as long as the if scope's going on, but then once it's gone, it's gone. So that is your first introduction to scope. We will be talking about scope in a great deal of context throughout the rest of this course. So scope is definitely one of those sophisticated concepts in JavaScript. I think understanding scope is one of the differences between someone who can write JavaScript code but really doesn't understand it versus someone who really understands what's going on. So the takeaway there being, don't sweat it if you don't fully get it yet, but also pay attention as I bring it up over the course of next week, because it's a subtle thing that you really want to be grappling with. And the final thing I want to mention about scope before we move on is I mentioned var last night as being this kind of antiquated way of creating variables. One of the reasons we don't like var is because this scope thing, it's called X now, sorry, is this scope thing doesn't apply with var. That was one of the upgrades they added to the language when they released ES6, which is the version of JavaScript that introduced const and let. So var does not play the cool scope game, which to a beginner might be like, oh, well, I don't want to have to deal with scope or not realizing if it's defined or not. But trust me, this is one of those things that's this is a reason why you shouldn't use var, is because the more you get comfortable with thinking about scope, the better of a developer you'll be. So that's my big plug for scope and another kind of why not to use var example. So now that we've talked about scope, we have this like awesome tool in our tool belts to talk about all these new tools in a more sophisticated way. All right, so let's move on from the topic of scope, and I want to talk to you a little bit about comparison, which comes up a lot in the context of an if statement. So let's say that we were, let's say if we were doing some sort of DMV software, so some sort of, we're trying to figure out if people are ready to be permitted to drive or licensed to drive. So we would definitely want to look at their age. And this would be a good scenario for a conditional because it's going to change based on what their age is. So we're going to have to be comparing their age. So a little reminder from last night is that we have these comparison operators built into the language. So we could write something like if age is less than 16, and that's going to be true because, we might want to say, is it less than 15 if we were checking if someone was able to be permitted. We could always do less than or equal to, or greater than or equal to. So we have these 4 basic mathematical comparers built in of this less than, greater than, less than equal, greater than equal. Of course, sometimes we want to know exactly what a value is. In that case, we could use the triple equals. So if we were curious if someone was exactly 16, we could write age triple equals 16. And that's going to be false in this case. So why the triple equals? It seems like it should be this, right? Well, remember that this line of code means reassign 16 to age, which we can't do because it's constant. So in JavaScript, we have to be very precise with the symbols we use because our code's being read by a computer, which is very precise, not a human mind, which could probably figure out based on context what I was trying to say. So the single equal sign never, ever, ever in the language is used for comparison. It is only used for assignment. So this is a really common beginning mistake because we're used to, from our math classes, thinking of equals as being a way of comparing things. But we have to use the triple equals. So there you go. If you want to compare, use the triple equals. I will also say that there is a double equals. The double equals is not recommended for new developers because it is a source of confusion. So just to give you a little idea of what's up with the double equals does not care about type. So as we talked about last night, the string 16 and the number 16 are not the same thing. But a double equals compare will say they are. A triple equals compare will not. So a triple equals is more robust. It's saying, are these things exactly the same? So for you guys, for now, start by just using the triple equals. And as you get better at JavaScript and more comfortable with the idea of type, you can start to use the double equals in some scenarios. The last comparison operator I want to show you is not equals. Sometimes you want to know if someone is not 16. So in that case, we just do a exclamation point, which refers to not in JavaScript, followed by 2 equals. So just think of replacing the first equal sign with an exclamation point. There is also a exclamation point equals, which is kind of the not equivalent of the double equals, but once again, don't worry about that one right now. So not equals and equals. Ta-da. There you go. All right. So those are some comparison operators. So let's just show you a little example of how you might use those in an if statement. So if we were trying to figure out if someone is, let's say if the age is less than 16, then we could do something like console log, no driver's license. And we see that we get that log. If we change this to 22, now our if statement wouldn't run. So this is a little bit of a review of last night. I've taught you a couple more comparison operators, but just this reminder that the thing inside of the parentheses is our conditional. And yes, that needs to be a Boolean, but lots of things can turn into Booleans. For example, comparisons are a way of creating a Boolean out of a non-Boolean. However, it turns out that we can do some even crazier things with our conditional, which is what we're going to talk about next. So there is something in JavaScript called truthiness and falsiness. And I will say out of the gate, let me write this out, falsiness. I will say out of the gate two things. One is I did not just make those two words up, even though I know it sounds like I did. Those are real terms in JavaScript, truthiness and truthy and falsy, truthiness, falsiness. The other thing I will say is that if you are coming from an object-oriented language, you will probably cringe at this. I personally started in Java, and I remember when I learned this in JavaScript, I was like tearing out my hair. I was like, it's a Boolean, it has to be true or false, it can't be truthy, but it's actually a really useful thing. So let me teach you about what truthy and falsy means, and then I'll show you some cases where you might use them. So the idea behind truthy and falsiness is that every single thing in JavaScript is truthy or falsy. Let's do truthy, falsy. So as we know, there are only two Booleans, right? True and false. And as you might guess, true is truthy and false is falsy. But it turns out that every other thing in JavaScript, no matter what the type, also has kind of a de facto true or false value. So what I mean by that is, let me set something up. So we know that if we have, one second, I'm bad at typing and talking. You'd think I would be better at typing and talking, given what I do, but give me a second. Okay. So as we know, if we plug into our condition a literal Boolean, like true, the if statement is going to run. If we plugged in false, then the else statement would run. But what we haven't tried is what if we plugged in a non-Boolean? Let's try plugging in the number 3. Well, it turns out that JavaScript is set up so that we don't get an error. You might think if you plug a non-Boolean in as your condition, shouldn't it throw an error? Turns out no, and that's because of truthy and falsy values. So 3, notice that the if statement ran, and we got truthy logged out over here. That means that 3 is truthy. It is considered to be true when it's plugged into a condition. Turns out the same with 7, the same with negative 7.3. You might be starting to think, are all numbers truthy? And it turns out that all numbers are truthy except 0. So every single number will be treated as true except for 0. 0 is treated as false. So we might think of this truthy, the truthy test as being this idea of is there data, is there content? So if there's any value, any numerical value, then we treat it as true unless it's 0, in which case we're saying, oh, there's nothing there. So it's treated as false. Let's talk about strings now. It turns out that all strings are also truthy, except the empty string. Remember I mentioned this yesterday, that you can actually create a string that has no characters in it just by doing a pair of quotes. Well, an empty string is going to be treated as falsy. So falsy is going to be an empty string. So that pretty much covers strings and numbers. And then the other two data types we learned yesterday were undefined and null. And as you might have guessed, both undefined and null are considered falsy. Oops, undefined and null. So it turns out that most things in JavaScript are truthy. Pretty much by default, things are going to be considered truthy. But there are, of course, a couple exceptions: 0, the empty string, undefined, and null, all of which in some way kind of indicate that something is missing. So why does this exist? When would we use this? As I mentioned, when I first learned this, I thought it was extremely stupid, but then I started coding with it and realized that it's incredibly useful. So let me show you a little example of when you might want to use this idea of truthiness. So let's say that we were working with some sort of users, and so we had a username variable that was coming in. But for whatever reason, we needed, if the username was missing, or if our name was missing, let's actually just make it a name, not a username. For whatever reason, our web application needed to default people to John Doe if it were missing. So missing data could look a few different ways. It might come in as an empty string. It might come in as undefined or null. But in any case, if there's no text or no value there, we want to set a default. So actually, I'm going to make this let. So if we could write something like if no name, which is to say if name is missing, because if something is falsy, the not version will be true. So if name is missing, then we could say, all right, let's set it to John Doe. So in this case, we see that, uh-oh, what happened here? Why did that not happen? Sorry, there is some sort of see. Now you guys get to watch me debugging live. What have I done wrong? Super weird. So if name is, sorry guys, it's been a long week. Maybe I will try a slightly different, slightly different example. So if we were dealing instead with a score of some sort, maybe we want the score, the default of the score to be 0. So, you know, so if someone had left this, if we were doing a survey of some sort and someone had left this blank, so if we're missing the score, then we want to set it equal to 0. Let's see if this works. Cool, that one worked. I don't know, I'm sure I'll rewatch the video later and realize I had done something totally, totally obvious. So the score is missing in this. You know, if we were, for example, I did a lot of, when I did data aggregation work, I did a lot of pulling values out of Excel spreadsheets. And a lot of the times things would come in as empty strings if someone had left a square blank. So if our score is left blank, we could say, okay, if the score is missing, if there's no score, then let's set the default to 0. So if this comes through as a empty string or as a null value, we see then that we can set a default to 0. However, if it came in as a 4, then this if statement would never run. So the takeaway from this, and I apologize for this being longer than I intended because of my egregious error before that I still have yet to know what I did wrong. But the takeaway here is that this truthy and falsy thing is really useful. And in my experience, the time we use it the most is when we're trying to check if something is missing. So a lot of the times you will see this not in the condition, which is saying, if this does not exist, if this is missing, and what's really great is because of this truthy falsy thing, is this will cover the case of something being 0, being an empty string, being undefined, or being null. And in all of those cases, this if statement will run and we can set a default. So I would encourage you to use truthy and falsiness moving forward if you ever need to set a default. So that's the idea of truthiness. And as you might have, uh-oh, I think sorry, I think my face has disappeared from the corner of this lesson. Let me see if I can fix that real quick. Oh, well. Well, as long as you guys can still see my screen, it's probably fine. So another little takeaway from this is that if you use the not operator with something that's truthy, like a string, it will turn into the value false. And if you use the not operator with something that is falsy, like the empty string, it will turn into the value true. And you can take this one step further, which is if you want to change a falsy value to the value of false, you can run this with the double not. So the double not will actually change a falsy value to false and a truthy value to true. So if this were a full string, we could change it to true using the double not. And you'll see some of that on the homework tonight. Okay, so let's move on to some logical operators. So for any of you guys who have some experience in formal logic, whether it's via classic philosophy or if you've taken a discrete math class, this will look familiar. Otherwise, you might be learning some new things here. So let's take a look at logical operators. So we've seen some mathematical operators, things like pluses and minuses, etc. We have seen some comparison operators, which is a way that we can compare values, compare numbers certainly, but also even compare things like strings. And now we're going to see logical operators. Logical operators are ways to combine or change Booleans. So we've actually already seen one logical operator, which is the not. And the not is the most simple logical operator. We know that the not changes true to false and false to true. So true becomes false, false becomes true. So that's the not operator. The next one I'm going to teach you is called or, and it's represented with the double pipe. So or is mostly what it sounds like, but it's an inclusive or. So think about it as if something was true or false, that becomes true. So the or is basically saying it's a way of combining two Booleans, and we're interested in if at least one of these is true. So if at least one of the two values is true, then it becomes true. If both values are true, it still resolves to true. However, if we ORed two false values, now it becomes false. So let's use a little example, and I'm going to come back to this idea of if it's raining. So let's say that we have something that if it's raining, we're going to say that's true, and then we're going to say if it's snowing, which will make that false. So if it's raining or snowing, you might want to bring an umbrella. So let's do an if statement. So if it is raining or if it is snowing, we're going to console log out, grab an umbrella. So notice that it logs out grab an umbrella because though it's not snowing, it is raining. If it were snowing but not raining, still want to grab an umbrella. Seems kind of silly to say true and true. I guess maybe if it was sleeting. But if it's not, if it is neither raining nor snowing, then we would see that the log does not appear, right? Because both of these are false. So or we're asking for at least one true value. That is what the or is all about. And we can keep oring. You know, we could also throw in its own sleeting category or a hailing category and just keep throwing them together. So we have to combine at least two, but we can keep ORing together as much as we want. So that is our next logical operator. The other one I want to show you is called and is represented by the double ampersand. So this one's a little more strict. Both values must be true. So let's say that we want to go to the beach. So we would want, wait, actually, let me think about this. I need to come up with some of these examples in advance, so I'm not making these up on the fly. Okay, so for and, maybe it's, let's say that we're trying to go to a party, and we of course need to be, and it's a potluck. We need to be invited in order to attend the potluck, and we also need to have a dish because no one likes to be the person who shows up to the potluck empty-handed, except it's kind of fun to show up to the potluck empty-handed and eat everyone else's food. But that's not good form. So our web application, which lets you know if you should go to a party or not, requires that you be invited to the party and you have brought a dish. So in that case, console log, you can go to the party. So right now I've set invited and have a dish to true, which means that we can go. But let's say that you made some awesome salsa, but no one invited you to the party. Too bad, you're gonna have to eat the salsa by yourself, which maybe isn't the worst thing that's ever happened. If you got an invitation, but you've been busy all day and you didn't make a dish, maybe you shouldn't go to the party. So notice that whereas or would have triggered as true if at least one more true, the and operator requires both of these things to be true in order for it to resolve as true. So if they're both true, the if statement will run. If not, and of course, if they're both false, then you definitely shouldn't go to the party. So we can combine these ands and ors as much as we want. We can do true, and there is an order of operation, but I would say for now, just practice making sure that you're using parentheses. So how would we read something like this, a little more complicated? Well, start with the parentheses. What is false or false? Well, we know that for or to work out, it has to, at least one of them has to be true. So we know that false or false is going to resolve to false. So then we could say, okay, well, what's true and false? Well, true and false is also false. So we could deduce that this entire line of code resolves to false. There's going to be a bit of this on the homework tonight. So once again, if you don't have much experience with formal logic, it's a little challenging to do this. And I'll admit that the homework is designed tonight to kind of drill you on this, because you don't have to be formal logic experts in order to write code, but the faster you get this down, the better, because when you're writing if statements, you want to be able to write the right condition in your sleep. So we'll be drilling you on these tonight. I would just say on these more advanced statements where there are multiple ands and ors, just figure out what the parenthesis is going to resolve to first, and then think about the thing as a whole. So there you go. Those are some logical operators. And as just to make it even more complicated, you could always throw a not somewhere in there to make it even more confusing, or throw a not on the front. And don't worry, there's nothing this advanced in the homework, except I think in the stretch exercises. But you can do some pretty crazy stuff with these logical operators. So they're good things to understand. And they're also kind of like Booleans in general, a little window into what's going on really deep down in the computer. These logical operators are very important to how the code really runs at the bottom of everything. So there are logical operators. All right, so the next thing I wanted to show you is called an else-if statement. So as you might have noticed, if-elses are really great when you have two options. But sometimes in life, you have more than two options. So let's say, actually, let's use this party example. So let's say invited is true, made food is false. So, you know, we might want something a little more sophisticated that doesn't just automatically rule you out if you haven't made food. So let's say if you are not invited to the party, Actually, wait. Let me think this through. Okay, so if you're not invited to the party, then we might console log, don't go. You don't want to go to a party you're not invited to. That's how drama breaks out. But let's consider a slightly different condition. So in this case, we might say, oops, else if. So now we can put in a second condition. So let's say if you are invited and you have not made food, so we're kind of playing around with some of these logical operators. So you really try and read these things as if they're in English and they'll make more sense. So if you're invited and you haven't made food, then maybe you should cook something. And then our final option would be, by default, if neither of these are true, then we could say, okay, you are invited and you have made food, so go party. So right now, because we're invited but we haven't made food, the second category is going to trigger, which says make something and go. If we weren't invited, but we did make food, it doesn't really care because we didn't get an invitation. So now we have three options. And I know I've made these conditions a little more advanced. It's good to get you used to these ideas of operators, but it doesn't have to be that sophisticated. It could be as simple as you have an age is equal to actually, I'm not going to do this example because it's on the homework. Yeah, I mean, it could be as simple as if you have a value and you're curious if it is positive, negative, or 0. So you might say if x is less than 0, then negative. Else if x is triple equals to 0, you might console log 0. And then otherwise, if it's not 0 and it's not negative, we know it's going to be positive. And in this way, we could determine if our value is positive, negative, or 0. So the big takeaway here is that if-else statement or else-if statements allow us to have multiple conditions. And in these, I've just showed you 3 options, but you can have as many as you want. So how this works is it first checks this condition. It checks condition number 1. If this is true, then we log out line 4, and we're done. It doesn't check anything else. But if this is false, then we check the next one. So we only move on to the next one if it's false. And then finally, at the end of the day, if none of our conditions are true, we always default to our else. So still, it's true that only one of these could ever run. It's just now we can throw in a third option and a second condition to check. So else ifs are really nice to know if you're trying to do a slightly more sophisticated bit of control flow that requires more than 2 options. So I did want to show you guys that. And you will have practice with that on the homework with a little "Are you 21 yet?" related question. All right, so that is all I have for you in terms of conditions. But I do want to show you loops before we quit for the night. And loops are pretty paramount to writing good, interesting, sophisticated, dry code. So I'm about to introduce my favorite term, which is dry. It stands for don't repeat yourself. So let's say that we wanted to write something that counted from 1 to 3. Actually, we'll do 0 to 3. So we start at 0, and then we log 1, and then we don't want to write out more console logs, so I'm going to copy and paste 2 and 3. So we have successfully written a bit of code that counts from 0 to 3. But this is not dry code. I have, first of all, copied and pasted, which should be your first clue that maybe you're not writing dry code. If you find yourself copying and pasting large chunks of code, that's a bad sign. The other way we can tell is just these 4 lines are not exactly the same, but they're very similar, and there's a pattern to them. So instead of writing out 4 different versions, maybe we could do something better. And if we were trying to count up to 50, you would sure hope that you wouldn't have to write out 51 console logs. And yes, this is where looping comes in handy. So I'm going to write out a loop that does exactly the same thing, and then I will break down exactly what's happening. Okay, so in much less code, I have just written the same thing. And what's cool is that if I want this to go up to 50, I just have to change one thing and bam, I've just written something that counts all the way up to 50. So what in the world is going on in this loop? As you might have guessed, loops are ways that if we ever want to run the same line of code or a similar line of code multiple times, we write a loop. So let me break down what's happening here. We have the for keyword, which tells us that we are writing a for loop. And there are a couple different types of loops. Right now, we'll just be exploring the for loop. So we write a for loop with the keyword for, followed by conditions. We actually have 3 conditions in the parentheses, which I will break down for you in a minute, followed by some curly brackets. And inside of that, we have a console log. So the thing inside of the for loop is going to be what repeats. And as you might have guessed, if you were thinking about what we talked about at the beginning, we create scope. So here's another example where we create scope. Now we have a for scope. So everything inside of this scope, inside of the curly brackets, is going to run however many times our conditions dictate. So let's take a look at those conditions. The first thing is our starting place. We usually by default use I as our counter. So we have to declare I and give it a starting value. And as you might have guessed, we have to use let because I is going to be changing. This is only our starting value for I, so we definitely want to use let or else we will get in trouble. Next, we're going to declare when we want to stop. So we're saying, I mean, really it's telling us when we want to continue. So we continue, I'll just do cont, as long as I is less than or equal to 50. So keep looping as long as this thing is true. So this is our starting value. This tells us when do we want to keep going, as long as I is less than 50. And then the last condition is the change. We have to be changing I in some way. So we're saying increment I. I mentioned that the plus plus operator was going to make a resurgence tonight. Here it is. So as long as I plus plus is true, or as long as we keep plus plussing I, we'll keep incrementing until we hit this stop condition, until I becomes greater than 50. And then we'll loop through this however many times we want. So let me bring this back to this example of 3. So it's going to log out 4 times. So what's happening here? Well, we start out by letting I equal 0. Then we check our condition. Our condition is true. Then we run the loop. So we get console log 0. And then at the very end, we increment. So this incrementation happens at the end. So then we're up to I equaling 1. We don't ever go back to our starts. We check our continue condition. We're still good. We log out 1, and then we increment. And we keep going until we increment up to 4. So even though there's no log, we actually, at one point behind the scenes, I is equal to 4. Unfortunately, what happens for little 4 is that we go over here, we check this. This is false. It fails. So line 7 never executes. So behind the scenes, I actually gets all the way up to 4, but then our condition fails, so we never run the console log. So, and notice that we're able to use I inside of our actual scope to increment this. And as you may be wondering, does this declaration exist in global scope or inside the for scope? It's kind of confusing, right? Because it's not inside of the block, but it's in the condition. Well, it turns out that that I is in the scope. So if we try to access I outside of the scope, we are going to get a reference error. And once again, this is actually a really nice thing because now the next time we use a for loop, we can still use I and not have to worry about it being set to some unexpected value. So a few things to keep in mind with looping is these conditions are pretty important. So what happens if we screw these up? Let's say if we say as long as I is less than -1. So we're starting at I, we're incrementing, but our condition says I has to be less than -1. So in this case, our loop never ran because by default, our condition is false. So we have to make sure that our condition is going to be true sometimes, or else our loop won't run. We can have an opposite problem though. What if our condition says as long as I is greater than 0? Sorry, greater than or equal to 0. Now we just created an infinite loop. This is something you want to avoid. Luckily, Replit has a little range error catch built in, so you will not destroy your computer by accidentally writing an infinite loop, which would be very bad. But you still want to avoid infinite loops because they are never really useful. So why was this an infinite loop? Because I starts at 0 and we're increasing I, so I is always going to be greater than or equal to 0. There's no way this could ever be false. So we have an infinite loop. Something to avoid, but something that will inevitably happen a time or two as you're getting used to these. A couple other things with loops. We can see that this condition of plus plus isn't the only condition we could have. If we wanted to count down from 10 and stop at 0, so in this case, this is actually a good condition. I is greater than or equal to 0. Now we want to do minus minus because we're counting down instead. Another thing we could do is we could actually change the value of I. So we could say I equals I plus 2, or we'll do minus 2. So now it's decreasing by 2. So whatever is in here has to actually change the value of I. And remember, the plus plus minus minus operators change the value of I. In this case, I've used I to decrease it, and then I've reassigned it. I've resaved a value into I. So I is changing. But if I just did I minus 2 over here, this doesn't change I. So we get another infinite loop. So make sure and you'll be playing with a lot of different conditions in the homework tonight. So make sure that this way that we're changing I actually is changing I, or else we will have problems. The final thing with loops is another little cool thing having to do with scope. It turns out that there are some keywords that only exist inside of special scopes. So actually, let me put this loop back to something a little more normal. So now it is counting from 0 to 9. So let's say that we hate the number 3. We just hate it. We don't want the number 3 to ever run. So how would we do that? Well, we would want to check if I is equal to 3. And then we somehow want I to not log whenever I is equal to 3. So we might say if I is equal to 3, oops, triple equals, my bad. Always triple equals. Continue. And then down here, we'll console log I. So what's happening here? Continue is a keyword that only exists in the for scope. And it says, quit running this current, it basically says, quit what we're doing in this loop, but keep looping. So in summary, notice that 3 is missing. So in the case that I is equal to 3, you're saying continue the loop. Don't read on. Don't ever see what the next lines of code are here for this one particular case, but keep looping through. So continue is a good way to skip a certain section of the loop or to have a special behavior on one particular value. So that's something you might do with a loop, is continue. There's a similar thing called break. Break is a little different. Break is actually saying stop the loop altogether. So once we hit 3, we're just done. So we only got up to 2. So continue, it's a little confusing because continue stops one iteration of the loop. It just stops one of the loops. Whereas break just says quit the loop altogether. We're done. We want to be done. So if you want to have kind of a extra stop condition built into your loop, you could use the break keyword. And you'll have a chance to play with these two things in the homework. And a final note on scope is that because these only make sense in the for scope, if you try to use a continue or a break outside of a for loop, you're going to get an error. And this is another example where the error message is actually extremely helpful. It says unsyntactic break, which means you used break in the wrong way. And it tells us it happened on line 13. So we can go, oh, that doesn't belong there, and get rid of it. All right, there you go. That is all the crazy control flow stuff that I have taught you for tonight. You know a lot more about using if-else statements and some of the cool comparisons and logical operators you might use, and I've also introduced you to the loop. Let me go over the homework for tonight, and then we will, and then I can answer any questions, which I see there have been a lot coming in, but okay. So the first assignment is a reading code assignment. This is what I talked about when I said that I was going to be drilling you guys a bit on, oh, that should be results, not result. But yeah, I said I was going to be drilling you on these logical operators. Here it is. So with this, I would recommend do not plug these into a different replit unless you're really stuck, because you won't learn anything if you just, you can solve these really easily by plugging these into another replit. That's not the point of this. So what you would be doing is going through and saying, okay, well, I know that true and true is equal to true, so you just assign this. So I'll give you the first one. We know that true and false is going to be false because both values have to be true. So you'll go through and actually assign the result answers based on what you think these logical operators will resolve to. And as you go on, you see that they get a little more advanced. We have some nots, we have some parentheses, some variables, and then a really convoluted one, a few really convoluted ones down at the bottom. So there you go. This is your way of getting really comfortable with ands and ors and nots. And of course, you can run the tests to see which ones you have right, and you can submit at the end. Though the tests are a little cheap in this too, because if you got it wrong, there's really only one other answer it could be. So maybe don't rely on the test too much until you've really thought about these quite a bit. So the next homework assignment is all about loops. So we've written out some loops for you, some portions of loops. If we have written out the conditions for you, don't edit those, just edit what's inside of the for scope. In some cases, you have to write them from scratch. In some cases, I think maybe not. But yeah, so we have different fun things. In some cases, we're decrementing. In some cases, we're incrementing. It's your job to log out whatever we requested you logged out. And then at the very end, we have a little else if practice where we're trying to figure out if you can drive, vote, drink, or retire based on your age. So you'll have to come up with a few different categories here to double check the age. And in each case, you'll be reassigning these. And once again, run the test when you're done to see what you've gotten right and what you need to take a second look at. And as I said last night, with this one, feel free to open another replit and play around if you want to get a better idea what's going on, because there will be mad console logs going on with all these problems. So it might be worth it to open a separate replit just to tweak each problem one at a time. So that is the homework for tonight. As with last night, just press submit when you're done, and definitely stick around for your group stand-up afterwards so you can discuss everything you learned and struggled with and what you thought was interesting and what you thought was frustrating and all that good stuff. So it is just a little bit past 6, so I want to answer some of these questions, and then I'll give you time to do the homework. Okay, we have, just going through, we have a question about how to use continue. So let me show you another continue example that might be a little clearer. So here's a for loop, and I'm going to throw a couple console logs in here. So we have our first console log and our second console log. So if I run this as is, we just get both of these console logs logged out 10 times. But let's say that sometimes we wanted to skip the second one. We might say if I is less than 5, we'll just do if I is equal to 5, then continue. So what we're saying is that when I is equal to 5, we're not going to read the rest of this code down here. We're just going to continue on to the next thing in the loop. So think of continue. This keyword has always been confusing to me, but think of continue as meaning continue to the next iteration of the loop. And if you guys aren't familiar with this term iteration, it just means basically version. So every time this code runs, it's an iteration. The first time it runs, it's the first iteration, the second, etc. So continue means continue on to, sorry, not the let, the next iteration. So we don't finish the current one. whatever comes after the continue will not run. So notice that in one case, our second is missing. So when I is equal to 5, we never get to line 11. So this is a way of saying, don't bother with the rest of the code in this loop. Continue on to the next value of I. All right, we have a question about, are negative numbers falsy? No, the only number that is falsy is 0. All other numbers, decimals, negatives, whatever, are going to be truthy. We have a question about, is there a reason that this I++ doesn't have a semicolon? Yeah, good question. So if we put the semicolon in, we would get in trouble. So really, the simple answer is that it's just how the syntax is. It's just expected to be in front of the first condition, the second condition, not the second one. Maybe a slightly more sophisticated answer would be that the parenthesis kind of serves in the same way the semicolon might. The parenthesis does a good job of telling the code, okay, we're done with the third condition, so the colon isn't necessary. The reason that it throws an error is just a choice on the JavaScript developer's part. They just didn't want you to put a semicolon there for whatever reason. So the semicolon at the end is not only not needed, but will in fact throw an error. We have a question, is the answer for exercise 1, question 1 correct? So the answer I put in, I don't even remember the answer I put in. If I put in false, then yes, that is correct. Because if you ever have a false statement with an and, the whole thing is going to be false. If I accidentally typed in true before, which I may very well have done, then no, that was wrong. All right, so we have, let me scroll up. We have a question, what does the new promise error message mean? Well, promises are something that are really cool, but a bit more advanced than anything we're doing in this class. So I'm not going to answer that. I'm a bit curious what you were doing that prompted the new this error message. If you want to post that in Slack or send that to me, I'd happily give it a look, but I don't know that addressing that will be useful to the class at large. So we won't get into that right now. I see a question about, sorry, scrolling up. We have another question about const and let, which is something I went over last night, but I will happily go over again because I think it's quite important. So I'll get rid of this loop. So the difference between const and let is that a const variable, which is constant, can never be reassigned, whereas a let variable can be reassigned. So if I try to put a new value into x, which is constant, I get a syntax error. If I try to put a new value into y, I'm allowed to do that. As far as use cases, always default to const unless you have a good reason to use let. For example, using let inside of a loop with I is not only good, but critical because we know by definition I should be changing. I is a counter. It is designed to change. But if x were referring to, something like something that shouldn't change, I'm trying to think of a good example for a number that doesn't change. Maybe if x refers to your social security number, it should be constant because your social security number should not be changing unless you're, robbed a bank and fled to Mexico. So that, but generally speaking, we don't like our social security numbers to change unless we're trying to start a new identity. Okay, so there's that. Let me see if there are any other questions lurking out of sight back here. We had a question about if Ruby was covered in the main curriculum. Ruby is not covered. For anyone who doesn't know what Ruby is, it's a really great language that actually makes, there's a framework called Ruby on Rails, which makes making web applications super easy. Well, not super easy, but it's a great tool for making web applications. So Ruby is a cool language. Ruby on Rails is a really popular framework, something I've worked with a little bit, but we do not cover it in the course. just to give you guys an idea, I think our philosophy is more that we would rather really focus on JavaScript and give you guys a thorough understanding of JavaScript. Because I will say that once you have a thorough understanding of JavaScript, learning something like Ruby becomes really simple, or even learning something like Java or C becomes much easier. So we start by just really diving into this one language so that you guys are well equipped to learn new languages on the go. Okay, we have a scope question explaining about global scope. So global scope is kind of a weird term because it's almost, understanding global scope almost doesn't help you, because it basically, global scope is saying like all things are allowed. Like recognizing global scope exists is kind of like recognizing that there is air in the room. It's true, but it's a little arbitrary. So when we create something in global scope, like this variable, it just means that this variable is available anywhere. I could use it, if I wanted to log it out here in the global scope, I could. If I were in a for loop, I could also log X. So remember, when I created this for loop, I've created a new scope. So if we think about global scope as being like the living room in the house, the for loop would be like a closet or a bedroom or a bathroom, something that's behind a closed door. So this is our for scope. And then, not to be confused with your horoscope, or if we created an if statement, this is also a new scope that we've created. So right now we have several scopes. The global scope is like the overall umbrella scope. Everything fits into it. But then these are two little special scopes that only exist in between the curly brackets. So because X is a global variable, which just means it was declared in the global scope, all these logs work. The logs inside the loop work, the logs inside the if statement work, the log in the global scope works. However, if we created something called Y inside of our for loop, oops, let's create Y. And if I try to log Y here, and let's also log it out here globally, I'm allowed to log it inside of the loop because that's where we're actually declaring it. But when I try to log it on line 11, I get a reference error. And when I try to log it on line 14, I also get a reference error. So the takeaway here being that because this was created in the for loop, it can only be used in the for loop. So things in the global scope can be used anywhere. And that's why I said that thinking about the global scope on its own doesn't really tell you much. It's just saying that a variable you declare regularly can be used anywhere in the code. It really becomes subtle and important when you're actually thinking about specific scopes like the for loop scope or the if scope, because, oh, that's not for. Because now the rules of a variable declared inside of the scope is slightly different. So I hope that shed a little more light on this, and I'll say once again that I think scope is probably the most sophisticated topic we've talked about so far. So if you don't 100% get it yet, that's okay. We'll keep coming back to it as we go along. We have a question about while loops and if while loops have scopes. So I am pretty sure they do. I don't really ever use while loops. So there's something called a while loop, which is like if you had, let's do let x equal 0, while x is less than 3, console.log x, and then x, we'll do x plus down here. So to me, a while loop is just like a jankier version of a for loop. So there might be like some weird scenario where I would use it, but I pretty much don't use while loops. But let's check and see if it has scope. So if we say let y equal 3, I would think it does. Yep, so while loops also have scope. I wouldn't see why they wouldn't, but you never know with JavaScript. All right, well, I'm going to wrap up the Q&A so that you guys have plenty of time on homework. I appreciate you guys hanging out tonight and learning all about loops and if statements, and have fun practicing with your ands and ors tonight. I'm like a total logic math nerd, so I secretly, sadistically love putting you guys through these nerdy exercises, but don't hate me too much for it. It will be useful because you'll be able to write your conditions in your sleep once you get used to them. So have fun with the homework. As always, ask questions in Slack, ask questions in your stand-up, and this is the last class for this week. We will resume on Monday of next week, so I will see you guys then. Have a great weekend. I always like to say at the end of this Thursday class that there's a big temptation to spend a lot of time just going over this again and again this weekend and working on code. Give yourself a day or two off. It really will help solidify things, and you'll come in on Monday feeling fresh. So don't grind too hard on this over the weekend. Weekends need to be for resting, or else our brains will explode. So that is all I've got for you guys. Thanks for sticking with it, and I will see you guys next week on Monday. All right, have a good night.